In this video, we're going to learn how to find the measure of an angle given other measurements of a right triangle. So in this case, we are given a diagram. We're given a description of the problem at the top. You always want to double check that the description matches the diagram. In triangle QRS, the measure of angle S is 90. QR is 8.2 feet. QR is 8.2. And SQ is 4.2 feet. Find the measure of angle R to the nearest degree. So the first thing you want to do is locate angle R, because that's your reference angle. Then you want to decide what is the relative position of the sides you have been given as they compare to angle R. Well, this side is opposite angle R. And this side is a hypotenuse. It is adjacent to angle R, but we only use the word adjacent in reference to a leg. This is the hypotenuse. That's more important. Hypotenuse. Next, we want to decide which trig function are we going to use. Well, this is where that handy little mnemonic comes in. So write it down. SOHCAHTOA. I am using the opposite and the hypotenuse, OH. So I want to be using sine. Sine of angle X is going to equal 4.2 over 8.2, the opposite over the hypotenuse. Now, at this point, I need a calculator because I'm not going to expect you to do 4.2 divided by 8.2 in your head. You can use any calculator, and I will be teaching you different calculators, but let's try this one today. 4.2 divided by 8.2. And the calculator gives me an answer accurate to many decimal places. Sine of angle X is equal, or I'm going to round off, so approximately or almost equal to, I make it a squeedly equal sign, 0.512, let's round up to 2, right, because it's 51219, so I'd round that up. Now I need to find the measure of angle X, so I need to go backwards to undo taking the sine of angle X. So I'm not going to take the sine of this number. I'm going to take the inverse sine of this number. So on the calculator, there's a symbol here right above my sine button that says sine with a little -1 above it. That's inverse sine. So X is going to be approximately equal to the inverse sine of 0.5122. This is not an exponent, it's just up high like one. So to get to that on this calculator, I've already got the number on the screen. I'm going to want to do my second function to get to that second function. Second inverse sine, and I want to paste in the last answer I had on my calculator. Well, on these calculators way down here, it says ANS, that stands for answer. So I can paste in more accurate decimal points than just rounding this off and do second answer, and that's going to paste in the answer I want right there. And I hit enter, and I get my answer. So X is about equal to 30.8-ish degrees. Now they wanted us to round off to the nearest degree, so that means it's really, I'm going to be rounding up. So X is about 31 degrees. Now once I was at this step, I could have used my handy-dandy trig table, which is available in your Google Classroom as a material. In a trig table, you just look for the number in the appropriate column and then read off the angle. So I'm looking for a 0.5122 in my sine column. Well, I go down my sine column, the numbers are getting bigger and bigger and bigger and bigger. Keep going, keep going. Oh, here we go. 0.515, 0.500. So 0.5122 would be less than this, but not much. I'd be between 30 and 31 degrees, but closer to 31 degrees, which is what we got. And there's your answer. Let's try another one of these. Again, you want to double check that the information provided in the question matches your diagram. I have triangle LMN. The measure of angle N is 90. MN is 8.6 feet. Watch your units. NL is 6.4 feet. Find the measure of angle M to the nearest degree. Well, here's angle M up here. What is its position relative to the other two? Well, it is opposite and adjacent. So I'm going to be using tangent because tangent is that TOA, opposite and adjacent. So the tangent of x is going to equal 6.4 over 8.6. Again, I'm going to use a calculator. Let's try a different one this time. Let's try one of these exceptionally fancy calculators. I'm going to do 6.4 divided by 8.6. I'm going to get my decimal. Again, for our purposes, since our final answer is going to be rounded to the nearest degree, we can just go ahead and say, oh, round it off to about 4 decimal places should be enough. 0.7441. Well, let's go further. 86. Ooh, life is exciting. Now I want to find the tangent of x that gives me that. I want to find the angle x that will give me that ratio when I do the tangent. Again, I could use my handy trig table. In this case, I'd be looking in the tangent column for something close to 0.74. So I'm going to go down my tangent column. Here's 0.7, here's 0.75, here's 0.72, 0.74 is closer to 0.75. It's 37 degrees. So I think that's going to be my answer. But let's check and see. It's another way to check if your calculator's in the right mode. So I want to do the inverse tangent. So I want to go backwards, not use my tangent button, but to use the inverse tangent, which involves that second feature. So x is going to be approximately or almost equal to the inverse tangent of this long decimal. That goes on forever on my calculator. So I'm going to do second tangent, and that pastes in the inverse tangent. And again, I could paste in the answer, and again, just like the other calculator, there's that A and S down there, and I could paste it in. And it tells me something that doesn't match my trig table. Well, gee, Ms. Long, what's going on there? I must be in the wrong mode. So I push the mode button right there. And sure enough, I am in radians mode. Do you see where it says radian versus degrees? I always want to be in degree mode in this course. You'll deal with radians next year. So now I want to quit and I want to do this again. So I'm going to do inverse tangent, but I can't paste in the answer because it'll give me that answer. So now let's use just that decimal. 0.744186. And now it gives me an answer which is closer to what I had already figured out from the trig table. X is about 37 degrees because we're rounding to the nearest degree. And once again, a logical, well-ordered mind puts a nice box around the answer so it's easy to find it.